Hello and welcome to this lesson about the converse of the Pythagorean theorem. The learning target for this video is using the Pythagorean theorem to determine if triangles are right triangles. So first of all, I want to kind of get into what the Pythagorean theorem is and then what the converse of it is going to be. So the Pythagorean theorem, and I'm just going to kind of draw it out with pictures, states that if you have a right triangle, so a triangle with a 90-degree angle, then you can do the whole a squared plus b squared equals c squared thing, where a, b, and c are on the triangle like that. Converse is where we're going to take these statements and we're going to flip them around. And so that is how you do the converse. And so the idea behind the converse is that if a squared plus b squared equals c squared, then we have a right triangle. Okay? And so it actually boils down to something fairly simple. All you have to do is take your three sides and see if they follow the Pythagorean theorem. A squared plus b squared equals c squared. And so with that being said, let's take a look at an example. Let's say we have a triangle whose side lengths are 9, 40, and 41. The question is this a right triangle? So, right triangle. So what we do is we let A and B be the two smaller ones, and the big thing that we really have to keep in mind here is that the biggest one has to be C. So this one has to be C. And then we just see if it's true. So we'll go 9 squared plus 40 squared, and then we're going to use this unofficial mathematical symbol of equal sign question mark to see if it equals 41 squared. And so we have to take some time, crunch our numbers, and see if that's the case. We'll get 81 plus 1600, and then the question is, does that equal 41 squared, which is 1681? And I think maybe we can kind of see where this is going. 1681 actually equals 1681. Check. Therefore, yes, this is a right triangle. So yes, right triangle. Let's take a look at a second example. Let's say we have a triangle with side lengths 8, 10, and 12. Now again, you have to let the biggest number be C. So has to be C. Now we just check it out. 8 squared plus 10 squared equals equal sign with a question mark, 12 squared. 64 plus 100 is equal to 144, and that's is equals with a question mark. And what we end up getting is 164 equals 144. That is not the case. And so this could be a triangle, but it's not going to be a right triangle. So not a right triangle. And that would be our answer there. And so really, that's what the converse is. It's all about taking some numbers and applying it to the Pythagorean theorem. If it works in the Pythagorean theorem, you've proven that you have a right triangle. If not, oh well, it's not a right triangle. Now, I want to give you a pro tip, and that has to do with something called Pythagorean triples. And I really want to go over this because this is something that people who write math tests just love to incorporate into a geometry problem. And so Pythagorean triples are numbers, whole numbers, that work in the Pythagorean theorem, straight up. So there's no decimal approximations. It's sort of like the first example where you have 9, 40, and 41. Now that's a rather obscure one. So there are more common ones. And some of the other common ones that you might want to commit to your memory, especially this one right here, 3, 4, 5. And so if you have a right triangle and it's 3, 4, and 5, or if you have a triangle with those side lengths, it is a right triangle. It works with the Pythagorean theorem. Another one is 5, 12, 13. Another one is 8, 15, and 17. And really, and then you got 9, 40, and 41. For the most part, though, these are the big ones that you're going to see a lot in your math future. where you're going to have triangles that are 3, 4, 5, or 5, 12, 13, and you just have to know that those are right triangles, they're Pythagorean triples. Now, what someone can do to disguise these Pythagorean triples is to times each of these by a constant factor. And so, for example, you could have a 3, 4, 5 that's disguised as 9, 12, and then 15, where all we've done is we've taken 3 and we've times it by 3. We've taken 4, we've times it by 3. We've taken 5 and we've times it by 3. So you could also have multiples of 3, 4, 5, 5, 12, 13, 8, 15, 17, and those are considered Pythagorean triples as well. So I just wanted to inform you about that because, again, that's something you'll probably see a lot in your math future, and it will just help to have all that under your belt. So good luck with your homework, and let me know if you have any questions.